The hyperbola is another conics section. The definition of hyperbola is as follows. A hyperbola is a collection of all points in a plane the difference of the distance between 2 points fixed points, the foci, is a constant. We call the transverse axis is the line containing the foci. Okay, this is a little bit different. In the ellipse, we had a sum. Now it's a difference. It's the same idea, though. So I have an ellipse. I have somewhere on here, a hyperbola on here. I have somewhere I have a center. I have some foci. I have some vertices. So here's my foci. Here's my vertex. And my graph looks like this. So here again, the curve is embracing the focus. So I have some A, B's, and C's. My distance from the center to the vertex is A. The center to the focus is C. And then what I really do is if I have a center here, and I know I'm going B in this direction and A in this direction, so here's my vertices and here's the other part, I can draw a little box and I can draw my asymptotes, and then I know exactly how my graph is because it approaches the asymptotes of the hyperbola. And when we do some graphing, we'll see a little bit more about that. My equations are, if my transverse axis is in the x direction, then it's x minus h squared over a squared minus y minus k squared over b squared equals 1. Notice a minus sign. And this is if it's in the x direction. And if it's in the y direction, so this is one that looks like this. If it looks like this, it's y minus k squared over a squared minus x minus h squared over b squared is 1. So the positive one is the one that the transverse axis direction is. And I also know that I have a squared plus b squared equals c squared now, because notice c is bigger, it's bigger than a. So a does not need to be bigger than b in this case, it just has to be under the positive part of the equation. I have eccentricity again. And it still is c over a, but now we know that c is bigger than a, so that means that my eccentricity e is always going to be bigger than 1. And if the eccentricity is close to 1, is approaching 1, then it gets curves away quickly, and if it's large, then if e goes to infinity, as it goes to infinity, the hyperbolas look like this. They're almost like lines.